Last year I made a video I called Debunking Determinism. Now it wasn't a good video. I don't make good videos. So it was with some dismay that I heard a user who I don't remember, somebody I don't watch normally, about 2 weeks ago I would say, more or less, in some context, I don't know what the context was even, said something on the order of, and I paraphrase, "I reject the notion of free will because the principle of determinism renders it impossible," or something like that. That was the meaning anyway. Again, I don't know the context, because when I heard that, and couldn't pay attention to the rest of the video. Probably wasn't worth paying attention to. Anyway, I'm at a bit of a loss here, because I'm not exactly sure what I need to do, but I need to do something, because this notion of determinism, I think, is dangerous because, first of all, it is false. It's provably false, and yet it forms the premises for so many nihilistic philosophies that we encounter here on YouTube and in the world at large. And nihilistic philosophies are counter to the goal of philosophy, in my opinion, since that goal is supposed to be to find a prescription for living the good life. Now, I don't have a whole lot of use for that notion, because I don't think a philosophy or a single prescription can exist for everyone to live a good life. It can only be applied here and there to the right people that fit the premises of a philosophy. But that said, let's have at it again and see where we can go with this. Now, before I made that first video, I didn't do any research at all. I just turned on the camera basically and said what I knew. This time I didn't do much research either. You don't have to. But I did do a little bit. So I learned a little bit that I didn't know. Not much, just a little bit. And I'll hopefully get to that if I can remember, because I tend to forget where I was going as I make these videos. Anyway, first bit of research I did was to read the Wikipedia article on determinism, which may not be the same article now as it was then, because these things change. But when I looked at it, it's a pretty bad article, obviously written by a die-hard determinist. He only made one good argument against determinism, and he didn't do a very good job of presenting that argument. However, it's short and sweet, so I can read you the whole thing. I quote, "All uranium found on Earth is thought to have been synthesized during a supernova explosion that occurred roughly 5 billion years ago. Even before the laws of quantum mechanics were developed to their present level, the radioactivity of such elements has posed a challenge to determinism due to its unpredictability. 1 gram of uranium-238, a commonly occurring radioactive substance, contains some 2.5 times 10 to the 21st atoms. Each of these atoms are identical and indistinguishable according to all tests known to modern science. Yet, about 12,600 times a second, one of the atoms in that gram will decay, giving off an alpha particle. The challenge for determinism is to explain why and when decay occurs, since it does not seem to depend on external stimulus. Indeed, no theory of physics makes testable predictions of exactly when any given atom will decay." Now, that was very oddly put. I don't want to say it's inaccurate, because he used the word about when it was crucial, and he hedged here and there also. He hedged here and there, and he's talking about something that has such a long half-life that the rate of change is not going to be that significant over the period of time that the article that he wrote is going to be up to be read. So, okay, he didn't really do much in explaining the problem. Nevertheless, this is the hard fact. These radionuclides, like uranium-238, like iodine-125, and God knows how many others, do exist, are well understood, are used daily. They're everywhere, all the time. You cannot look at them and say they don't exist. They don't do what they do. But if you're going to say we live in a deterministic universe, that's what you have to do. You have to say they don't exist, they don't do what they do. Now, is somebody supposed to buy the hard proof that's sitting in front of them, that anyone can look at and see? Or are we going to believe this theory? Well, apparently in many cases we're going to believe this theory. I'm kind of at a loss to go beyond that, but I will try to. Now, when I made the first video, I talked somewhat about my lab experiences working with iodine-125. And I'm not sure if I talked about the right things or not, so I'm going to try to make some finer points about it. First of all, the gamma detector is essentially 100% sensitive, which is not a great thing. It's a good thing sometimes, it's a bad thing other times. But if a gamma ray hits it, it gives you a count. So here's the problem. I give off gamma rays. Gamma rays come in from the sky. The material that the gamma ray counter is made of gives off gamma rays. This is called background radiation, and it has to be adjusted for when you're making your account, but it can never be exactly adjusted for. But we can make an approximation to subtracting the counts from background as we make our counts of sample. So if you're dealing with picogram levels of I-125, for example, you might have a specific amount that, having subtracted your average background count, will give you counts of around 100 a minute. So that would be 1,000 counts over 10 minutes. Of course, if you count it for 10 minutes, you're not going to get 1,000 counts. You're going to get, I don't know, 1,050, 1,080, 1,200. And you'll divide that by 10 and you won't end up with 100 counts per minute. Or you could look at it in increments of 15 seconds. Instead of 1 minute, you could look at what did I get the first 15 seconds, what did I get the second 15 seconds, and so on. And you're not going to see 25, 25, 25, 25. That's not what you get. And this again is counting is after subtracting your average background count. No, that's not what you're going to see. You're going to see 35, 15, and so on. That's because the sample actually does vary in its output. Radioactive decay occurs as a natural logarithm. It's nonlinear, in other words. and it doesn't occur like clockwork in any given sample. It occurs in a way that indicates that it's clearly random, or I should say semi-random, because in the end it always ends up following its curve over time, but the shorter the intervals you're looking at, the more variation you're going to get. So clearly there's something going on, and I'm not going to say what, because I don't know, and no one does, that is not following any kind of deterministic law of nature. Now, the other thing I was going to get to that I mentioned, and I hope I can do this right. I looked up an article by Jean Bricmont, Bricmont. I'll put a link to it in the description. I think that'll be my only link. It was a pretty good, comprehensive article, which did take the deterministic position. And so did the Wikipedia article, to some extent, mention the ideas that this fellow had come up with. I couldn't really grok the article in its entirety and in all of its significance, because I tried to print it out so that I could read it at leisure, and it wouldn't print for me. I'm not sure if that was because I'm not a member of the site where it was or what, but I couldn't get it to work. I had to read it on my screen, and that's a pain in the ass for me. But what I got from it was this idea that the determinists, in order to maintain this deterministic philosophy, have tried to incorporate non-determinism into the deterministic theory. And it's not that hard to do when you're dealing with something like sensitivity to initial conditions, or chaos. Because even though the actual outcomes of chaotic systems are never predictable and can never be predictable, the patterns that they form are always very similar, or at least usually very similar. I can't think of an exception. Try as I might. I mean, there may be exceptions, but I can't think of one. So basically what they've done there is change the word determinism to mean non-deterministic, which is fine with me. If you want to say that an unpredictable result is non-deterministic because it's clearly going to be a certain class of result, I don't really have a big problem with that, because it still means that we live in a non-determinist universe. Basically, let's go back to my old favorite, which is dice, which are not a chaotic system. They are not chaotic. They are not, well, definitions are a problem here. In general, I would not call them a chaotic system. To some extent, yes, sensitivity to initial conditions does play a role. Yes, there are situations where if you set things up perfectly, you can reproduce a result with dice. But in another environment, you can't. Say in a casino where there's a craps table, there is no way you can make a legal roll and set it up so that no matter how good you are at palming the dice, there's no way. Anyway, it does display a random result within the constraints. Okay, and it is deterministic because you know a priori that you're going to get a number that isn't 1 or less, and you're not going to get a number that's 13 or higher. And it's absolutely determined that a priori it's determined that you will get a number between 2 and 12. So you can say it's deterministic for whatever that's worth. It actually is a pretty deep concept. It really is. Change of costume. I was editing and I decided there was just no way to get around a reshoot here. A couple of the main arguments I come across are, one, and most importantly perhaps, a refusal to accept acausality, and the other I don't take quite as seriously, but it does come up as an argument from perfect knowledge. I guess I should address them. Now, I have heard it said that the behavior of radionuclides is acausal. I don't know that any scientist says that. I would say that in the absence of any knowledge about why they do what they do, they seem acausal. I personally would not suggest that they are acausal, but I would suggest that any causation is separate from a knowable reality in this universe. I don't know that to be true, but it's what I intuit. Even given that, if it were true, it still remains a truth of this universe that determinism is an impossibility, given the existence of radionuclides behaving as we know that they do. Now, as to the argument from perfect knowledge, it goes something like if we could know everything about everything in a system and make measurements from there, we could perfectly predict the final outcome of the operation of that system. It goes something like that. I think the people who try to make this argument are stuck in a Newtonian view of the world with the clockwork universe or something like that. But without even addressing that as an issue, every measurement is only as good as your measuring stick, whatever that may be. I'm using that as a metaphor because there are obviously different measurements in length. Anyone who's taken a college course in science surely remembers the dreaded sig figs. What that was an acknowledgement of the limits of precision of measurement, and that every final digit in any measurement is always an estimate. Now, obviously there are finer and finer measurements that can be made, and we're constantly improving our ability to measure things. But if you look into the work of Max Planck, you will find that there are absolute limits imposed by the universe itself on the precision of measurement that could ever be available. And this is true of essentially every conceivable dimension. So in invoking this perfect knowledge, what you are saying is that you are postulating the existence of God to make these measurements, or you are in some way trying to imply that the material and forces of which you are speaking have knowledge of themselves. But again, this metaphorical, if you will, knowledge of itself in materials and forces cannot exceed the refinement that the materials and forces themselves impose. So it's an argument from and to nowhere, in my opinion. And these limitations on the precision of measurement apply universally. They apply even to the most controlled experiments. So in any measurement situation in physics, for example, a problem of ballistics where you know the exact forces applied and you know how to calculate the final resting place of a projectile, you can only determine that in advance within the limits of precision of your most imprecise measurement. So to say that you got it exactly right is exactly wrong. You don't know how right or wrong you actually were. And you never can know how right or wrong you actually were. You can only know that you were right within the limits of measurement you were able to make. So to say that it's a deterministic thing is a speculation. It's purely a speculation. Okay, I think I should say something about free will. I'm not going to say a lot because it's a really tough nut to crack. The problem is in language and definitions. Obviously, we don't have free will in all cases. Obviously, some people have more of it than other people do. What we have are a system of constraints. But to say that the human brain, at least, is not capable of exceeding its inputs is absurd. There are many examples in history, and if there were none, there would be no progress, because it's when the inputs, or when the output is greater than the sum of its inputs, is when we get progress. It's when we get new ideas. And if you're going to try to say that we never get new ideas, then you have a problem with causality. Then you have a problem with cause and effect. But I know that in some situations I have free will. I know it. Whenever my impulse is to do something, and I stop myself and say, I better think about this, that's free will, I think. Clearly, free will is something that evolved because it was useful. And animals do show free will, in my opinion. Less so than humans. They have fewer degrees of freedom in which to carry out their will, let's put it that way. But my cat, for example, will be lying on the floor sometimes, and I'll pull a string past her, and she'll spot it, and she'll jump up and go running after it and grab it. And that's what her instinct says. She should do that. Another time I'll do exactly the same thing. I'll run the string past her, and she'll be laying there, and she'll see it, and she'll look at it, and then she'll look at me, and she says, "What the hell are you doing?" So obviously she has a choice, and sometimes she makes one choice, and sometimes she makes another choice. Why would a cat even make a choice? So, you know, free will is just one of those self-evident phenomena, and I think the burden on anyone who denies it is to disprove it, because I think it's the default position. I think a lot of the atheists on YouTube are against free will simply because it's a tenet of Christianity. I really do think it's just a prejudice there. But I can't fathom why some people are so determined to destroy the notion of free will. Because in doing so, they are in fact destroying their raison d'etre. Anyway, that's about as far as I can go with it. I mean, it's not a hard thing like determinism that can be disproven with hard science. And speaking of hard science, I think I want to say one final thing about determinism. And that is that obviously the scientist is prejudiced towards determinism because his job is to identify, enumerate, and quantify deterministic forces that constrain our choices, that allow us to make confident predictions about cause and effect. That is the job of the scientist, is to identify these fundamental things so that the engineers and what have you can put them to use. And there's no denying that many of these, well, all of these things that are identified are deterministic. Of course they are. They have to be. If they aren't, then they can't be identified, enumerated, and quantified, can they? I mean, this is the fundamental tension, right? But it's nevertheless a fact that radionuclides are ubiquitous. There's no denying, there's no refuting what they do, and the fact is that they have an effect as acting as a primary and unpredictable cause. They do have an effect on everything.